Today we're going to look at the 2013 AP Calculus BC of our Q number 2, which involves solving the area between two polar curves, finding the position of a particle moving along the curve, and finding the position and velocity vector of that particle. Since this is number 2 on the exam, you're allowed to use a calculator to solve this problem. This question gives a drawing of the two polar curve equations and shades the area they want you to solve for. And don't forget that they also give you the angles where the curves intersect, so you don't need to solve for that separately. In part A, the question wants you to simply find the area that is shaded in the drawing. There are actually many ways to do this. You can find that you have 2/3 of a circle and add the little sector in the middle. Or you can first notice that there is half a circle and going from there. Or the most complicated way, splitting the drawing down the middle in half, and then solving for each half separately. And lastly, you could take the area of the circle and subtract the little unshaded piece. But in my opinion, the easiest way to do this problem is to look at the 2/3 of the circle and add the area of the little sector in the middle. Now we can start writing out the expression for the area. So 2/3 of a circle plus the integral from pi over 6 to 5 pi over 6 of the 4 minus 2 sine theta graph. Now we input that into our calculator. And we round to 3 decimal places for the area. Of course, you can also do the middle sector another way. You can take pi over 6 to pi over 2 of the 4 minus 2 sine theta graph and multiply that by 2, but since this problem gives you the intersection points already, I think it's just simpler to do it from pi over 6 to 5 pi over 6. For the scoring of this question, the integrand is worth 1 point. The correct limits and constants make up another point, and your answer is worth another point. So always remember to write the expression for solving the problems even if it is the calculator section. Part B is slightly wordy, but to simplify it a little, the problem basically wants you to make a polar question transition into a vector question by setting theta to t squared. So in this problem, you want to find the time in which the x-coordinate of the particle's position is -1. You also need to notice that they want the time to be in the interval from 1 to 2. Now to go from polar to parametric, you need to realize that to find the x-coordinate, it is equal to r cosine of theta. You set theta to t squared and replace r with 4 minus 2 sine theta, while also replacing the theta for t squared. To get the time in which the particle's position is at -1, you would set this expression to -1. Then to get t, you would move -1 to the right side and graph the equation in your calculator. One of the zeros of the graph should be the value of t. After graphing this expression, notice that there are many zeros. Then notice in your problem that t is between 1 and 2. Therefore, the value of t is approximately 1.427 if you truncate your answer and 1.428 if you round up. For the scoring of this question, you earn 1 point for correctly writing the expression for x, which can be in theta or t. You earn another point for just setting x to -1. And lastly, 1 point for your answer. In part C, the problem wants you to find the position vector in terms of t and the velocity vector when t equals 1.5. This part is very similar to part B. So to go from polar to parametric, we set x to r cosine of theta and y to r sine of theta. Then we just substitute r in and change theta to t squared. And then we'll have the position vector. To find the velocity vector at time t equals 1.5, we need to take the derivative of the position vector and substitute 1.5 for t. So taking the derivative using the product rule, we end up with these expressions for the x and y components of the velocity vector. Next, we just plug in 1.5 for t into the calculator for each component and write it in vector form. For correctly writing the position vector, you earn 2 points. For the velocity vector evaluated at t equals 1.5, you earn 1 point. So even if you correctly write out the velocity vector while plugging it wrong into your calculator, you won't earn any credit. In general, this question is fairly easy to approach. Just read the problem carefully and look for what information they give you that will make it easier for you to solve the problem. It is very easy to earn credit for this problem even if you try not to. Some common mistakes that may occur in this problem may be forgetting the 1/2 for finding the area of a polar curve. Also remember that vectors are written in triangular brackets, but I don't know how much College Board would account you for that. And always be in radians, especially in part C when you plug in t equals 1.5 for the velocity vector. Some things to remember while solving this question is to be diligent in your writing. Even if this is the calculator section, write out your expressions and then solve them on your calculator. You earn credit for simply writing out the integrand and the correct limits. Another thing to remember is that you don't need to distribute your answer like in part C, because if you distribute, you actually might make an error. Here are some problems that are similar to the question we covered today.